So what we're going to do today is the topic is circle geometry or Euclidean geometry of circles. And today is really about warming up and just getting familiar with some of the stuff that goes with circle geometry. So here is question number 1. I'm giving you a circle, and the circle has some shapes inside of it, and it has some angles inside of it. And I want you to try and work out the value of A. So it says here, determine the value of A. And in the chat, if you know what the value of A is, won't you put the A, B, C, or D that goes with that? This is what I call the warm-up question. Do you think it's A? Do you think it's a B? And for those who know a bit about circles, maybe you can put in the chat, what is a useful idea about circles that might be helpful here? Or maybe somebody can come online and give us a tip. Don't give us the answer, but give us something that you know about circles that maybe can help us. Just put your hand up and you can let us know what that tip is. When you see circles, what do you see? Or I'll put this another way. What are these things in green called? So a full circle is 360 degrees. Yes, Anele, I agree. But what's the special name for these things in green? And you can put your hand up if you want to share a little bit. I'm just testing the waters to see how much you know about circles. These are the radiuses. Yes, Awang. So these two lengths are equal in length. OP and OQ are both radii of the circle, and so they're going to be equal in length. Okay, so radius is one of the words that we need to know about. Now, if these two are equal in size, then it means something about these two angles. These two angles have to be equal in size, because this is an isosceles triangle. Two of the sides are equal. Now, there's one other fact that we need before we can get an answer. Who would like to share that? Because it's nice to know it's an isosceles triangle, but that still doesn't let me know how to find A. I'd love for someone to share their thinking. You don't have to do right, but I just want someone to tell me what ideas they're thinking about. Or what facts do they think? I see in the chat, there's a couple of C's, a couple of A's. I will reveal the answer now. So one of the things about a triangle, oh, here we go, Regile has got it. So the sum of angles in a triangle is equal to 180 degrees. So what we know here is there's a couple of ways we can write it, but we could say that this angle over here is equal to A because of the fact that it's an isosceles triangle and the base angles are equal. And then we know 180 plus 98 plus A plus A, sorry, 98 plus A is equal to 180. So those three angles add up to 180. Then we can solve for A. So if we take away 98 from this side, we get A plus A is 180 minus 98. So, and then A plus A is 2A. So we get 2A is 82. And then if we divide both sides by 2, we get that A is 41. And so the correct answer is 41 degrees. So I haven't put the reasons. When we do this topic, we often have to, whenever we make a statement like this one over here, we would include a reason. But for today, I'm just focusing on the main ideas. So the two main ideas that we used here were, in a circle, you have radii that are equal in length, and a triangle adds up to 180. So that's an important idea for today. So what does, actually, let me just do a quick little vote. Thumbs up if that made sense to you. Thumbs down if that felt like I was talking Greek, or who knows what else I could have been talking. Okay. Cool. So whenever you think of circle geometry, you're always going to have these radii floating about, and these radii give you these isosceles triangles. And honestly, this comes up all the time. That's why I'm showing it first. And so just to give you a little bit of, because I can, I suppose, to show you kind of a little animation of how this works. So if you imagine, even if I do this, even though the angles are getting smaller, what you notice is that the angles stay the same. And if I made the circle bigger, let's see if I can do that. Oh, I can move it around. Can I move this? There we go. Ooh. Do you notice how the size of the angles always stays the same? Because the radii are always going to be equal. Okay. We are, Ayanda, we are in a new topic for, okay, let me maybe draw this for you. So if you think of a circle, so I'm drawing a circle, and we call this the center of the circle. Whenever we do this, these are called radius or radiuses, and then radii is the plural, and they will always be equal to each other. Now, if we join these points over here together, that gives us a triangle, which will always be an isosceles triangle, which means these two angles will always be equal. Now, depending on how flat, like for example, if my radii are like that, it doesn't look like radii. The size of the angles will be different, but the base angles will still be equal. And so that is an important idea, that if you have a triangle inside a circle, the base angles will always be equal if the triangle is anchored on the middle. So, and we just often, when we use that reason, we just say radii. Okay, we'll get back to circles in a second. Let's go a little bit back to Euclidean geometry first, because I can see we need to warm up to this. So I want everyone to I want you to do A and B. And what you need to do in A and B is you need to find for me the value of X. So you need to find the value of X in each of these. And if you can do reasons, that would be great. But initially, I want to see for A, put your answer in the chat. And then for B, put your answer in the chat. Because one of the things in circle geometry is we often have lines that cross each other. And we need to know a little bit about that relationship as well. Would anybody like to come online and tell us how to get A and B? Anybody? You will have my utmost admiration if you do. Okay, I see. Nice. Kelly, nice. Sino. So we would say X is 85 degrees, and the reason we use is vertically opposite angles. I'll do reasons at a later stage, but the main idea is that vertically opposite angles are equal. And then for B, anybody want to take the glory? Does anybody want to seize the day to tell me how to work out X? Because I know X is not equal to 120. But I'm wondering if anybody knows the trick to deal with the 4X.
We'd love to hear your voices, guys.
Sino, let's do this. What do you think I should do with the 4X?
Hi, sir.
Hey.
So the angles are vertically opposite. So you will take the 120 and you're going to say equals to 4x, and you will then divide the 120 by the 4 to get the x.
So then what do you get for x?
30 degrees.
Perfect. Okay, let's just do one more like this. Let's do C. Thank you so much. That was fantastic. Can you solve for x for me in question C? Over to you guys. See if you can do it. Today is like geometry's greatest hits day. We're doing a lot of the old classics, intersecting lines, radii. Been down this journey
sounds
before.
like a radio show.
It does. But Lebo, is the classics? I mean, you did this not so long ago, a couple of years ago still, but does this feel like, the classics of circle geometry? Or at least geometry?
Definitely, yes. They never get old.
Math doesn't really get too old, does it? No, that's fine, Akateko. We know load shedding is tough, and we also know that our lessons are recorded. And so, yeah, if you miss a snippet, you can always come back tomorrow, have a look at the snippet that you missed. Anybody willing to give me their working on C or share their thinking? See a couple of answers coming through. Yeah. Let's go to you, Pomaklak. Hello.
Hi, sir.
Hey. What do you think we should do?
So, sir, I did 3x plus 10 degrees
Yeah.
equals to 4x plus 5.
Okay.
And then I took the 4 to the other side.
Okay. Become -4. So like that.
Yes. X. Then I took the 10 to the other side. Then it became 5 minus 10. Then it was negative x
Okay.
equals to negative 5. Then I divided by -1 to get rid of the negative. Then it was x equals to 5.
I love it. Absolutely perfect. So x is 5. So that is really good. So we've clearly mastered this ability to find vertically opposite angles are equal. This will happen throughout geometry, and it seems like we all are pretty comfortable with that, which is fantastic. Let's go on to triangles. So I want everyone to do A and B for me. Now, you're given a triangle or two triangles, and I want you to try and find the X and the Y for me. Can I go back? Let's have a look. How about that? Is that helpful? I'll try and make it big enough so that everyone can see. So if you've done A, you can also do B. So I see in the chat, a lot of people are saying X is 68 degrees. And I agree with you, it is 68. I will put the reasons actually now that there's a bit of time. So we say angles opposite equal sides. So angles opposite equal sides. And basically that just is saying that is opposite that side and that is opposite that side. And so they must be equal. They must both be 68. Let's see if we can do X and Y here. Who would like to come on and share their thinking? Oh, I like the answers I'm seeing in the chat. Let's go to Faith. Hi, Faith.
Hi, sir.
Hey.
X is equal to 34 because it's vertically opposite angles. So
It's almost, it's not quite vertically opposite, because vertically opposite would be this, but you're close. So it's, can you see the reason above here? It would be this one, huh?
okay,
Angles
so
on the equal side, because
opposite sides.
yeah, no, that's fine. But that was awesome. 34. I agree with you. And then how did you get Y?
Which is equal to 68. So 180 minus 68 is equal to 112.
Yes, absolutely. And then the reason, and again, I'm doing this more for bonus, would be just be sum of angles in a triangle. There might be another acceptable variation, but that's the reason we would give.
Yes.
Thank you so much, Faith. That was awesome. Are there any questions or comments, ladies and gentlemen? So far, we've done radii, we've done intersecting lines, vertically opposite, and now we've done some stuff on triangles, which I think is great. So I think what I'm going to do, give me a thumbs up if you're feeling good, thumbs down if you're feeling a bit lost. If we're mostly feeling okay, I'm going to go back to circles now. Yeah. Okay. Cool. So let's have a look at vocabulary for circles. I just want to do a little bit of vocabulary with you because today is really, like I said, the greatest hits day. And if we draw a circle, I have what's called the center point. And often we call the center point O in circles. So that's not very exciting. We also have something called a radius. So let's call that one the radius. The red thing is the radius. Also not very exciting at this stage. However, what is the blue line going to be called? In terms of circle geometry words, what is the blue line going to be called? Yo, look at that. Fastest fingers on the chat there. So I'm seeing a lot of something called a diameter. And a diameter is just 2 radii. So I could have got a diameter like that, or I could have got a diameter like that. That would have also been a diameter. There's many diameters in a circle. So that's quite important. Okay, now we're going to get a bit more exciting. In the language of circles, what is that straight line called? If you like guitars, you might know this one. That's my cryptic hint. Does anybody want to come online and share this magical word with everyone? You close, but no cigar. Well, actually, it could be, okay, the segment's not wrong either. I would call the green line by itself, I would call it a chord. So the diameter is a special type of chord that goes through the middle. Every other straight line that goes from one point on the circumference to the other is called a chord. Now, we'll get to sectors and segments a bit later, but for now, I just want to make sure that we understand what the lines mean. So that's a chord. And the reason I said guitar people will like it is because if you play guitar, chords are an important part of that process, different type of chord. We're running out of colors here. If I take a point on the circumference and another point on the circumference, and I follow the curved bit, what is that line going to be called? That yellow line. Anybody know what that's going to be called? Yes, Oam. It's called an arc. 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 And when we deal with circles, if we have an arc between 2 points, this is called a minor arc because it fits inside a less than sort of 180. But if you have a minor arc, you'll always have what's called a major arc, which goes around the outside of the circle like this. And the major arc is just the bigger of the two. Okay, I don't know if I made that more complicated than it needed to be, but often in circles, they talk about like a major arc and a minor arc, and that's useful. Okay, I'm not going to do all the vocabulary today. I'm just going to do one more, and this is kind of a big deal one. This is a line that is touching the circle at just 1 point. Who knows what that's called? So a line that touches the circle at just 1 point is called a tangent. So there are more words, and I'm going to come back to them. But for today, these are like the big five. Okay, radius, diameter, chord, arc, and tangent. Although I've got one more. Oh, it's too good a question. I can't let it go. If I say to you, here's an arc, and it goes the whole way around the circle, what is that special type of arc called? An arc that goes the whole way around the circle. Who would like to come online? I'd love to hear your voice. What's that called? Ah, Letabo, Sine, there we go. Okay, so that's called a circumference. And again, the circumference is an important idea in circles, and you will hear me refer to these words later on. Cool. Let's do a little practice quiz. I want you to tell me which of the following diagrams show a chord, or which of the following diagrams shows a chord. Is it A, B, C, or D? So what makes a chord a chord? Okay, that was a little, I can see you guys are like, come on, sir, take it up a notch. So B it is. You're quite right. The answer is B, because 2 points on the circumference, a straight line that doesn't go through the center. Then I want you to answer this question. What is another name for the perimeter of a circle? Is it A, B, C, or D? Oh, a bit more debate here. So some people say B and some people say C. Well, I'm going to explain what B and C, because we haven't spoken about this word called sector yet. So the perimeter of the circle just means to go around the outside of the circle. What's the outside distance around the circle? And the correct answer is C. But what is, so the correct answer is C. But I want to show you what is a sector. A sector is when you have two radii that come out like this, and they cut off. It's almost like a piece of pizza. So this bit over here that is I'm coloring in is called a sector. And you also have what's called a minor sector, and then the major sector would just be the rest of the pizza. I also sometimes think about like sectors like an orange, like a sector of an orange. And so a sector is like a piece of pizza or a piece of the orange. And that's another word that comes up in circles sometimes. Let's do one more. Okay, we can't do that yet. Oh, we can't do that yet. Okay, time for a break. Ladies and gentlemen, we have been going for half an hour. And so it is time for you to let your body unwind. And so look at that happy chap. He just wants to stretch. So who am I to deny him? So can you please stand to your feet and let us do something to awaken our bodies. Level, if you can encourage our maths friends to stand up and stretch. Okay,
Guys,
and
please turn on your cameras. Let's see your lovely faces.
I had
Join
an
us
idea.
in the stretch.
Okay, let's start with this one. So stretch across. Oh, that feels good. And stretch it up on the other side. I had a feeling like I should bring some 80s aerobic music to Zoom, but then I just never got around to it today. So maybe next time I'll bring some.
I think that would be really cool.
No, I was just thinking like, that's what we need. Okay, let's do some little circles with your shoulders. Little circles, and big circles. Oh, feeling more
Musa
human.
is in the dark because of load shedding. They
Yep.
can't keep
And
us
let's do
down.
Small circles with your arms, bigger circles, and big circles. Oh, that feels good. I can feel my heart rate. Okay, now, last little bit of exercise. We're going to do jumping jacks. We're going to do 10. The way it works is a jumping jack is 1, 2, 3, like this. 1, 2, 3, 4, 5, 6, 7, 8.
And no doing it
9,
sitting down, guys.
10.
We can see you.
You think you're like, why am I doing this? Is the teacher just having fun with us? I sort of am, but there actually is evidence to suggest that it's helpful. There we go. So
I saw
that's
a lot
my
of
mental
cameras
life.
go off when I said don't do it sitting
Yeah.
down.
Guys, I promise, exercise, it's an investment in your brain. Okay. Next part of the brain break. I want you to take these 4 numbers and to make 24 using only the operations plus, minus, times, and divide, or brackets. You don't have to use every operation, but you do need to use every number. Ooh, I can definitely tell I did that properly. Find me 24. Oh, wow. Okay. Some people are super fast on the draw. So that's the first one. I'm also going to give you the second one just so that you have access to it. So can you make 24 with the blue? Same rules, just a bit harder. So I see a lot of students are getting the red one. It's just 4 times 3 times 2 times 1, which is 24. Nicely done, Timmy. Nicely done. Can you do the blue one? Okay, Hearties, what have you got there? 7 times 4, which is 28. And then minus 6. That's okay, there's a couple of ways to do this one, so keep your answers coming. Hearties, I think you do have something that works there. Same with Tsegofatso. So Sylvia, you write 4 times 6 is 24, but you have to use all 4 numbers. Oh, there's another way of doing it. Okay. So this game is called Maths 24, and let me just, so Harty suggested 7 times 4 is 28, and then you go 28 minus 6 plus 2. So you've used up all the numbers, and then you get 22 plus 2, and that's 24. And there were a couple of other ways that I saw in the chat that would work. Cool. Okay, so that was nicely done. So I hope you've enjoyed our little break. I do think that is well worth the time that we invested, but let's go back to the main attraction, which is circles. So I'm going to introduce one, maybe two more new ideas about circles today. And so before I introduce this idea to you, I want to talk to you about a circle, and let's talk about an arc. So let's take 2 points over here, and this, let's label our arc, and let's call this A, B, and then let's call the middle part O. All right, so in circle geometry, if you have an arc, there's a fancy word we sometimes use with an arc or a chord where we say an arc subtends an angle at the center. So to subtend an angle is almost like, let me write the word. Subtend an angle is almost like if AB subtends an angle at the center, it looks like this. That's what it means to subtend an angle at the center. And AB is almost acting like the base. Now, AB can also subtend an angle at the circumference. So let's do this. And there, I'm going to label this point over here C. So when students first hear this word subtend and making angles, it feels a bit like random to them. And I just want to point out what it means. And so this has the arc AB has subtended an angle at the center, which is the thing in yellow. And then the one at the circumference, I'll just label it green. Give me a thumbs up if you understand the language that I've learned. I mean, I've used now. Itumeleng, let's, okay, cool, you understand. Awesome. Okay. Now, there's a theorem in circles that deals with this idea. And I'm going to show you in a like animation how it works, roughly speaking. Okay. So if I take CD, I can change how long CD is. So let's stop down here. Here's my arc CD, and it subtends an angle at, okay, let's make it 54. It subtends an angle at the center, which is 54, and an angle at the circumference, which is 27. So that's one relationship. Now, if I change this to 104, you notice that I'm making the angle at the center bigger. And then if I look at the angle at the circumference, it's 52. Now, I want to ask, what do you notice about the relationship between the angle at the center and the angle at the circumference? Maybe someone could come online and help me explain what, and we can test out your idea. Let's go to you.
Hi, sir.
Hey.
How are you?
Very good. And you,
I'm good, sir. Thank you. Sir, I'm not sure, right? But
Okay, give it a go.
Isn't the angle at the center twice the angle at the circumference?
So in this case, it definitely is, but just to make sure, let's move. Oh, so if I move the thing on the top, it doesn't change. It stays fixed. That's interesting. Let's just try something else. If I change this to 120, looks like is on the right track. It looks like the angle at the center is always twice as big as the angle at the circumference. Give me a thumbs up if you agree with I'll try another one. Maybe I can make it like 140. Then I would expect it to be 70. Yeah, got it. So the key thing to notice is we have this thing in red called the arc, and it's making an angle at the center, and it's making the angle at the circumference. The other thing I want to name is, can you see it makes a shape almost like an arrowhead, like something out of Top Gun, right? So it looks a bit like, you get the shape that looks a bit like an arrowhead. Now, it's possible to get other types of shapes, But for now, the arrowhead looks like that. It might look a bit different if I drag this down. Can everyone see how it looks a bit different now? So if it's here, it looks like an arrowhead, whereas if it's here, it looks a bit more like a folded over butterfly or something. Nom Tandazo, let's go to you.
Afternoon, sir.
Hey,
How are you?
very good. And you?
I'm okay. I would love to disagree with Umta because
Okay.
the angle up was 54, and when you times it by 2, it gives you 108 instead of 107.
Aha. Okay. Mthandazo, you are so on the ball here. Now, the only thing that's happened here that is messing this up a little bit is that it is a rounding off problem. So there's a slight rounding off because this is a digital world, but I'm so impressed how quickly you picked that up. But if you had to construct this, you would see that it is always double the size. There was just a slight rounding problem with the actual animation. Okay.
sir.
But super well spotted. So let's see how this looks in a question. Here is a circle. I want you to find the size of angle H for me. So what's the size of angle H? All right. So everyone is happy that C is 100 because it's twice the size. And we can see the arc that is making the angle is there. And the angle at the circumference is bigger than the angle. Sorry, the angle at the center is bigger than the angle at the circumference. How much bigger? It's twice as big. Nicely done, Lumka, and nicely done, Atule, as well. Okay, so you seem to have got this interesting thing over here. Find me the size of angle X in this question. Okay, so everyone seems very happy that X should be 62 degrees. Now, when we do this in this topic, and I'm not fixating on reasons today, but I may as well give you some of them. The way we write this is angle at center equals twice angle at circumference. So it looks like that. So just at a later stage, this little thing is the angle sign. So that's an angle at center equals twice angle at circumference. That's the reason you'll often see it used, but we'll do a separate lesson on reasons later. You can all see that this is twice the size of the one over here. And so you correctly halved it to get 62. Faith, let's go to you.
So is there a shorter term for circumstances?
Half. So sometimes sometimes teachers say half angle at center. So if you're given the one at the center and you need to know, they sometimes write it like that. But let me come back to that in the lesson where I focused on reasons, just so that we can look at the metric. I do have the. Okay, well, let's actually bring it up since you've asked. So here is the official. Sorry, you must be getting like. Here's the official metric guideline thing. So that is, you're allowed to abbreviate circumference with circum. So you should stay set with that. Okay. But again, today is more about understanding than it is about obsessing about reasons. So let's go to this next question. All I want today is I want some better visual awareness. So which of the following is a correct way to write the unlabeled angle in terms of y? If you know what y is, what is the red one going to be? So we have to think which part of this are we dealing with? It feels to me like this is the arc. And then it makes an angle at the center. And then it also makes an angle at the circumference. And we can kind of see that this one must be smaller than this one. And how much smaller? Well, throughout this, we've either been halving or doubling. So I think this one is just going to be y divided by 2. And so it's going to be c. So if you had said 2 times y, what that would have meant is that this one was bigger. And we can see visually it's not bigger. This, like the hands are further apart. Like this is an obtuse angle. Like maybe it's like 120. Then this should be 60 if that was the case. And so that's why C is right. Whereas if we had gone with D, we were saying that this angle over here is 240. Give me a thumbs up if you understand how I got that answer. Thumbs down if you're feeling a bit lost. That was harder than the other ones. Okay, cool. Well done, everyone. And I can see a couple of students are still unsure. So the main idea is how do you, if you want to halve something, if I give you 120 and I want to halve it, do I times it by 2 to get half? No, I divide it by 2. But now imagine instead of 120 being 120, imagine 120 is y. So how do I get half of y? I go y divided by 2, which is the one over there. Okay, let's practice this a bit more, I think. Let's do number 15. Little bit harder. It's our last question for today. If I give you a circle that looks like that, I want you to work out what x is going to be. Okay, I can see quite a few students need a bit more things, so don't worry. We're going to repeat and practice lots and lots and lots. This is a bit sneaky, be warned. Think about which one is the bigger one, which is the smaller one. So I can't, this is not true. X plus 22 is not equal to X. What I need to do is I need to divide one of them by 2 to make them equal. Which one do I need to divide by 2? Do I need to divide the yellow side by 2? Or do I need to divide the blue side by 2 to make these two things equal? Are you team yellow or team blue? Okay. So we need to divide that by 2 to make them equal, because that was the bigger one. Okay, so let's see if I agree with you. Boom, Klaka, let's go to you.
Hi, sir.
Hey.
So I'm having a bit of a problem. Isn't like the rule for maths, what you do on the right side of the equal sign, you have to do it on the
Yeah,
other
it
side.
is. But you're quite right. So the problem is when I started this, I made the statement x plus 22 equals x. So I made the statement that this angle here is equal to, okay, well, let me actually do it the other way around. That this angle here is equal to that angle there. And that's not true. It's definitely not true. But we've learned today that the angle at the center is twice the size, or it's 2 times bigger. So if I want to make the yellow equal to the blue, I need to divide it by 2. So you're right, normally it does, but in this case, we're using a fact that we know. So now I am going to multiply both sides by 2. And when I multiply both sides by 2, I should get this. Okay. And then what do I need to do? So now I've got 2x on this side and I've got x on this side. What do I need to do? I think I just need to take the x to the other side. Don't I? So what's my final answer for x going to be? What's my final answer for x going to be? Yeah, 2x minus 1x is x. And so x is going to be 22. Now, if I'm telling the truth about this, let's just test this works in real life, or not in real life, but in the drawing. What is 22 plus 22 equal to? What is 22 plus 22? It's going to be 44. And what is the blue x all by itself going to be? It's just going to be 22. And that makes sense to me because it's half of the 44 that I started with. The drawing does look bigger than that. So I take it that the drawing looks a bit distorted, but that's fine. Okay, ladies and gents, we've done a lot today. And I just want to say well done on being part of the lesson. Today, we spoke about radiuses. We spoke about intersecting lines. And then we spoke about circles and radii. And then the main new thing we discussed was that the angle at the center in a circle is twice as big as the angle at the circumference. And that's the main idea that I want you to take away from today. And this is probably one of the most important theorems in circle geometry. And so if you've just got a picture of that in your head from today, then you are winning at life. So Annie has asked, why do we multiply both sides by 2? So because, Annie, I wanted to get rid of this 2 over here. So I multiplied this side by 2, and I multiplied this side by 2, but these 2's canceled out. So that's what happened. So, Lebo, can I ask you to put the poll up? So everyone, I know today is our first lesson, and there's many of you who are new, but yeah, I want to get a sense of how you found the lesson. Did you find the pace appropriate? Please let us know in the poll that we're going to put up in a moment. And yeah, this course is just a warm-up for circle geometry, but it's an important foundation because students often feel a bit rushed in this section. And so I want to make sure I give you a real good visual picture of what you deal with in circles.